Okay, so the last thing we looked at was we converted each of these fractions into improper fractions. 8 plus 3 is 11 over 4. So if you're unsure where I'm getting these numbers, multiply my denominator by the whole number plus the numerator. So 17 over 2, 17 over 4, and 17 over 8. So if we look at these improper fractions, there are also patterns happening here. Okay, if we look at our pattern, and I'm not so much worried about short to long. I want to stay within the short side. So if we look within the short side, 17 over 2 became 17 over 4. 17 over 4 became 17 over 8. And if we think about what happened from one step to the next, we actually multiplied 1/2. 17 over 2 times 1/2 becomes 17 over 4. 17 over 4 times 1/2 became 17 over 8. Let's see what happens over here. How does 11 over 1 become 11 over 2? Times 1/2. 11 over 2 becomes 11 over 4 because we multiplied 1/2. That's pretty interesting. Let's take a look at our other table. So if we look at our other table, let's get our improper fractions again. So I get 11 over 2 and 11 over 4, 17 over 2, 17 over 4. And again, multiplying by 1/2. And what's interesting is if we look at the tables together, in each, we're multiplying by 1/2 for everything. But when we lined up our diagonals, they all didn't match. But if we take a look a little bit closer, and in class, some people saw this, my short sides on one table actually match the long side of the other. The long side of this table match the short side. So because they switched positions, that's why we didn't end up having everything be scaled factors of each other or scaled copies. So even though the patterns are all the same, they still wouldn't match up because if we look here, these measurements match up with our long side. Right, so number 3 says, look at the measurements for the rectangles that are scaled copies of the full sheet of paper. What do you notice about the measurements of the rectangles? Look at the measurements that are not scaled copies of the full sheet. What do you notice? Okay, so you're going to fill in this area, but we talked in class and just now about the different possible things you can see. So the first thing is take a second and tell me, what do you notice about the measurements of the rectangles? Okay, so patterns. What kind of patterns do you find? And the second question, what do you notice? So these are the rectangles that are not scaled. What do you notice about those measurements? So the ones that were not scaled would be like C and B would be examples of not scaled. So if I looked at my two sets of information, if I compared C with B, what do you notice about the measurements? So if you compared the measurements of C with the measurements of B, what do you notice? Is there something that's the same? What could you write down that you notice? So your job is going to be to write down in number 3 some things that you noticed. Okay, number 4. Number 4 says, stack the rectangles that are scaled copies of the full sheet so they are all lined up at a corner. So this is just a picture of what we did yesterday, where we took the rectangles and we matched them up in the corner. And what you're going to do is you're going to take your ruler or your straight edge and you're going to line up your diagonals and you're going to draw the diagonal for each. And again, this is just a picture version of what we did in class. It says, on each stack, draw a line from the bottom left corner to the top right of the biggest rectangle. What do you notice? So you can write what you notice, but this, again, is something we talked about yesterday. So I would notice that the diagonal lines go through the corners of the rectangles. Now this last one, number 5, I'm actually going to show you. So number 5 wanted you to stack every single rectangle together and see what happens. Okay, so I'm going to do that, and as I do this, you're going to look, can you tell from the drawn lines which set each rectangle came from? So think about that as I show you. So we started out, you didn't see A, but A was the full sheet of paper. Okay, I don't know if I can even get this up high enough. Maybe not. Let's do this. All right. So here's my full sheet of paper, right? Okay. And then we can take B, put that in the corner. C, that one in the corner. D, and then E. Sorry about that. I'm holding this up midair. All right, so if we look at all 5 of our rectangles, what do you notice? If you look at the diagonals that are kind of jagged there, can you tell which rectangles would be the scaled copies? Okay, so you're going to answer number 5. Can you tell from the drawn lines which sets the rectangles came from? All right, so answer number 5. All right, next page is lesson 1. Or section 1.3. Now we are going to come back to this one. All right. So this is something that at another time we may come back to, but for right now, that's all we have for lesson 1. But we are going to go straight into lesson 2. Okay. So we're going straight into lesson 2. Unit 2, lesson 2, circular grid. Sorry about that. So we are going to dilate figures on a circular grid. Okay, so we didn't talk about the word dilate, so we are going to now. So dilation dilate or dilation is a transformation that shrinks or expands a figure. And we'll get more of a specific definition, more mathematical definition as we go through. But just so you have a little bit of an idea, we are going to be looking at a transformation that shrinks and expands figures. All right, so let's take a look at this picture. We have a new grid. Okay, we've seen an isometric grid, a regular grid. This is a new grid. It's a circular grid. And off to the side on your paper, you're going to tell me something you notice, something you wonder. So one thing you notice, one thing you wonder. Okay, so if you struggled to come up with something, I'm going to tell you a few options that you might have. So one thing that you might be wondering or noticing, so we'll look at the notice. So I noticed that, and you're going to tell me. So you might notice that the circles look like they're equal distances apart. You might have noticed that there are diagonal lines coming from, it looks like a center. You might have noticed that it looks like the circles have a center. Maybe you notice that it looks like it's broken up into some triangular type shapes. Some of you may have noticed that it looks like there are rings. Okay, so you have to write something that you notice. Then something that you wonder. You may be able to take what you noticed and turn it into a wonder. So if you noticed that there was a center in the middle, you could wonder, does that center of the circle have something to do with this dilate that we just learned about? Or why are the circles cut by these lines? Why are the circles look like they're the same distance apart? Will we use these to help us transform figures? What are we going to use this for, right? So there are all kinds of things you can wonder. So your job on your paper is to make sure that you answer and write something down that you notice and wonder. So go ahead and turn your page. Section 2.2, a droplet on the surface. So if you've ever seen in TV or in person a pond and a water drop falling on the pond, and imagining what happens when that water drop falls on the water, there's like a little bit of a ripple effect, right? And you can kind of think of this circular grid as that ripple effect. Here's our rock or drop of water that fell into the pond, and then we have a ripple that extends out. So this is our center, and everything extends away. All right, now if we look at our directions here, it says, the larger circle D is a dilation of the smaller circle C. P is the center. Okay, so remember our dilation. We're going to write this again. Okay, when a shape or when a figure is made larger or smaller. Okay, so that's a general definition of dilation. Center of dilation is very similar to the center of rotation in that it's kind of where, with a rotation, it's what you use to like rotate around. The center of dilation is what we use to figure out the large, like how to make it larger and how to make it smaller. Okay, so P is our center of dilation. All right, number 1. Draw 4 points not inside the circle. So we're drawing 4 points on the circle, not inside. Okay, so on a side note, when you are looking at the directions, when it says on the circle, sorry, let me get a piece of paper here. So if I had a circle, this is on the circle. I don't mean like, two-dimensional, the surface. This is not on the circle for our directions. This means on the circle, okay? So when it says draw 4 points on the smaller circle, so the smaller circle. Now there are a lot of circles, but we're talking about 2 in particular. Talking about circle C right here, right? This is circle C and circle D. So we're going to draw 4 points on the circle. And we're going to label them E, F, and G. So you can draw your points where I put mine, or you can pick wherever you want to go. The only thing I would suggest is you don't put them in the middle. You can. You don't have to put them where these lines are, but that's where I'm going to put them. The reason I suggest it is just because it'll be a little less work in a few minutes. And I know we all like that. So 4 points and label them E, F, G, H. Number 2 says, draw the rays from P through each of the 4 points. Okay, now a little side note, rays. Just so we kind of remember, a ray has a point and a line that goes on forever. So that's a ray. So draw the rays from P through each point. So you're going to take your ruler. You cannot be sloppy with this. Do not freehand this. Use a straight edge. So we're going to line up from P through E. I'm just going to go on as far as I can and draw an arrow. Then I'm going to go through F. Now, if you drew your point in between 2 lines, it's fine. You're still going to just use the ruler. It's just this looks nice and cleaner, and you have a line to follow, and it's just, some people find that to be just a little easier to kind of understand what's happening. So I'm going from the center through my point. And then H, so through center P and the point. Make that a little darker. Okay. So again, we went through and made all of these lines, so go ahead and do that. Make mine thicker while you get yours finished. Now, you may not have my same lines, but you should have 4 lines or 4 rays, right? Oops. Just want to make those thicker so that you can see on your screen. Yours do not have to be thick like this. Yours can just be regular. As long as you can see them on your paper, you're fine. Okay. Number 3. 3 says, label the points where the rays meet the larger circle. So my larger circle is circle D, right? So D is the large circle, C is the small one, right? So label the points where the rays meet the larger circle. We're going to label them E prime, F prime, G prime, and H prime. So let's go to E first. So I have my line that I drew through E, and my ray kept going, but it passed through circle D. So where it passes through circle D, I'm going to label it and mark it, calling it E prime. Now for F, if I follow my ray, I'm going to call that F prime where it meets that circle. G prime is right here, and H prime is right there. So we're dilating points. So for example, point F dilated from this position out to this position. Okay. So let's take a peek at number 4. 4 says complete the table. In the row labeled S, write the distance between P and the point on the smaller circle. So S is the distance from P to the small circle. Okay, the small circle is called C, right? In the row labeled L, write the distance between P and the corresponding point on the larger circle. So we want distance from P to large circle. Now these are the points. Okay, so just so you know what's happening here. All right. So let's take a look at our first row. So the distance from P to the small circle. So we need to see the distance from P to the small circle at point E, from P to F, from P to G, and from P to H. Okay, so from P to E, I'm trying to find a different color here. From P to E, how far is our distance? So from P to E, now when we count distance, we're counting circles. So it's 1, 2. Right? Do you see how that's 2? From P to F, it's 1, 2. From P to G, it's 1, 2. And from P to H is 1, 2. That distance is 2. This distance is 2. That distance is also 2. So all of our distances from P to these points on the small circle are 2. Now let's look at the distance from P to the large circle. So this one, we're going to go from P to the large circle. So for E, from P to the large circle, we went 1, 2, 3, 4, 5, 6. From P to the large circle, it's 1, 2, 3, 4, 5, 6. P to the large circle is 1, 2, 3, 4, 5, 6. And guess what? For H, it's also 6. So on my table, so our distance from the center P to the small circle is always going to be 2 units. The distance from P to the large circle is always going to be 6 units. Okay, let's look at 5 for a second. The center of dilation is point P. What is the scale factor that takes the smaller circle to the larger circle? So what do you think the scale factor would be to take the smaller circle to the larger circle? So when we're thinking about scale factor, you're looking at how it's enlarged or shrunk. So for example, it's doubled, or it's tripled, or everything is quadrupled, right? Or it's cut in half, or it's in fourths. So those are scale factors. So how do you think it changed from the small circle to the bigger circle? If we look at the table. Now with scale factors, this is like a multiplication. Oops. It's multiplying and dividing, right? If we multiply, it gets larger. If we divide, it gets smaller. So when we look at scale factors, it's a multiplication or a division, because multiplying and dividing are what make shapes expand or shrink. Okay, so hopefully you looked and you said the scale factor must be 3, because the distance from the small times 3 equals the distance to the large circle. Now you can write that in a different way, for sure. You do not have to write that like I did. But you do need to come up with a scale factor and how you know. And if we look at our table, 2 times 3, 2 times 3, 2 times 3, and 2 times 3. Okay. Next one. So again, we will get a little more used to this as we get through our examples here. That first one was just to kind of get a general idea of what's happening. So now what we're going to do is we will see a figure, and now we're going to actually dilate a figure. Okay. So in the previous activity, each point was dilated using a scale factor of 3. So those dilated points were 3 times as far from the center as they were from the original. So let me bring this back real quick. If I look at E and E prime is 6 away. So it's 3 times as far from the center as E is. You see that? everything gravitates from the center. So F prime is 6 away, F was 2. So F prime is 3 times as far. So since it's 3 times as far away, my scale factor is 3. Okay, so that's another way to kind of look at the scale factor, is comparing my distances. How did the 2 become 3? So using that information is going to help us here. And actually, on a side note, let's look at one thing first. You do not have this, okay, but I just want to reiterate what I just talked about, because there is a lot of chance for mistakes to happen. And so I just want to take a second and look again at how the dilation works, okay? Our center, everything always starts from the center. Every time we always go back to the center. So if I look from my center to D, the distance is 2, right? Now, if I go from my center to D prime, and again, you're just watching, you don't have this on your paper. My center to D prime is 4. So my original distance was 2. Now my new distance is 4. So this would be a scale factor of 2, because original times 2 gets me my new distance, right? So keep that in mind as we work. We always go back to the center. All right. Now let's come back here. So quadrilateral on a circular grid. Here is the polygon ABCD. Dilate each vertex of polygon ABCD using P as the center of dilation and a scale factor of 2. So P is the center, scale factor of 2. So we're going to make a little note here on scale factor that says original distance times 2 equals new distance. And this is all from P, or the center. Okay, so when I talk distance, I mean from the center. So we're going to label the image of A as A prime, and then label the images of the remaining 3 vertices, B prime, C prime, and D prime. So we're going to do this together. Remember, our scale factor is 2. Okay, so we start at P, and I go to A. So if I look at the distance from P to A, from P to A is 1, 2, 3, 4. So from P to A is 4. So on the side, from P to A, the distance is 4, right? So I take my original distance times the scale factor, and I get 8. So P to A prime is going to be 8 units. It's not 8 from A, it's 8 from P. So from P, I go 1, 2, 3, 4, 5, 6, 7, 8. And that's my A prime. Okay, let's look at B. So from P to B is 1, 2 units. Okay, so P to B is 2 units, right? So now I need P to B prime. Well, 2 units times 2 is going to be 4. So from P to B prime, we're going to go 4 units. 1, 2, 3, 4. Remember, it's not from B, we always go back to P. Now, you may have thought that it was going to be on the same circle, but it's not, because my distances are different here. So each one you have to do on its own. Okay, so let's look from P to C. So from P to C, it's 1, 2, 3, 4, 5. 5 times my scale factor of 2, P to C prime, is going to be 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want you to try D by yourself. Kind of running out of room on the side here, so we'll write it down below. Okay, so you try D. Okay, well, hopefully, if you're not done, hit pause so you can finish on your own. But from P to D is 1, 2, 3 units. 3 times 2, because my scale factor is 2, is going to give me 6. So from P, I'm going to go 1, 2, 3, 4, 5, 6. And there's D prime. Now, if you need to, go back and you can draw the distances. So you can go through and kind of make the markings. Oh, that's not 4, that's 5. Okay, so if you label your distances, we can see my original distance doubled gets me my new distance, right? Now we have to go back up here. Number 2. Number 2 says, draw segments between the dilated points to create a polygon. So take your ruler. We're going to draw lines between our points. Do not do this freehand. Use a straight edge. And also make sure that you're being accurate. We want to go to where the grid lines cross, right? And there's our new polygon. So answer number 3. What are some things you notice about the new polygon? So that's something I want you to do on your own. So on your own, I want you to look at the two polygons, look at the new polygon, and tell me something that you notice. What do you see maybe that's happening? All right, number 4. Choose a few more points on the sides of the original polygon and transform them using the same dilation. Okay, so here's what they mean. Remember, the points don't just have to be at the corners. Okay, the points can be anywhere. Now, I would suggest that you mark where it crosses like the circle and the grid line, because it's easier to tell if it's somewhere that crosses together. So for example, let's everybody plot that point, and we'll call it E. And let's look at our measurement. From P to E is 2. If my scale factor is 2, it's going to become 4 for E prime, right? 1, 2, 3, 4. So for number 4, tell me, draw your E and your E prime, and tell me what you notice. Okay, number 5. Now number 5 is going to be a little tricky for me because I have a lot happening inside my circle. Not sure what yours looks like, but if you have a bunch of stuff drawn, this might be a little bit trickier for you too. So 5 says, dilate each vertex of polygon ABCD using P as the center and a scale factor of 1/2. So now we're looking at halves, right? And actually, we're going to do the next activity with this one. So don't worry about 5 and 6. We're actually going to do this with the next activity. Just because I don't have enough room, and you may have a bunch of stuff drawn too. All right, so take a look at our last section here. A quadrilateral and concentric circles. So concentric circles looks a lot like our circular grid, but it does not have the lines, right? Our directions say dilate polygon EFGH using Q as the center and a scale factor of 1/3. The image of F is already shown on the diagram. You may need to draw more rays from Q in order to find the images of the other points. All right, so let's take these things one step at a time for a second. Step 1, Q is our center, right? So Q is our center. Everything radiates from the center. Everything dilates from the center, okay? So always dilate from the center, right? So first things first, we have point F. And our instructions say that our scale factor is 1/3. So if we take our original distance times 1/3 is going to equal our new distance. So we're taking 1/3 of our distance. So if I look at what's happening here from Q to F, my distance is 3. 1, 2, 3. Right? So from Q to F is 3. Three times 1/3. We multiply across, and I get 3/3, which is 1. So that means from Q to F prime, I'm going to go 1 unit. So that's the math of what's happening. Now, you don't always have to do this math off to the side. You might be able to come up with, breaking this into thirds. Because if I look here, there's a third, and a third, right? 1, 2, 3 thirds. So that's another way that you could kind of look at this. Now that all seemed fine until we get to my next points, because I don't have any of those lines. The last grid gave us lines. If you are not given the lines, you have to make them. You may need to draw more rays. So take your ruler, and we're going to draw a ray from Q through E. We're going to draw a ray from Q through G. And from Q through H. Okay, so draw your rays. These rays are going to help us with our distance. So again, the rays are going to help us find our distance. Now, if we look for Q to E, from Q to E, we have 1, 2, 3. So my distance from Q to E is 3. My scale factor is 1/3. So I need 1/3 of 3, right? 1/3 of 3 is 1. Now you can do the math off to the side or not, it's up to you. But let's take a look at G. So our distance from Q to G is 1, 2, 3, 4, 5, 6. So from Q to G is 6. Well, 6 times 1/3 is 6/3, or 2. So that means from Q to G prime is going to be 2. So go from Q, 1, 2, there's G prime. Now for H. 1, 2, 3, 4, 5, 6, 7, 8, 9. So from Q to H is 9. I need 1/3 of that. If I cut 9 into 3 groups, each group has 3. 1, 2, 3. If you want to do the math, Q to H was 9. 9 times 1/3 is 3. So Q to H prime is going to be 3 units. Then we're going to connect our points. Now, when we come back together, we're going to complete the summaries for lesson 1 and lesson 2, because there are some things that I want to kind of review and get two together. But your job is going to be to have a good set of notes. So the things I wrote, you should make sure that you have written down too, so that you're ready to summarize lessons 1 and 2. And that's it.